Example 2, given the graph of f of x equals x squared, describe the transformations. We have done that in the previous video. And then write the corresponding equation. We've done that. So we now want to sketch the graph of g of x. So to do that, because I've got a lot of reflections and transformations and I need to do mapping notation, I need to list some coordinates to apply those stretches and reflections. So to do this, I need to graph this. So I can just start with the table of values, or we know what this sketch is. I don't necessarily have to sketch x squared, but I find it helpful. So I know that this parabola is 0, 0, over 1, up 1, over 2, up 4. So I'm squaring however far I go over for this parabola. 3 over 3, 3 squared is 9. Because if I was to substitute 3 in here, 3 squared is 9. Negative 3 squared is 9. And I've got my points. So I'm going to leave this on here. I'm doing this in pencil. This isn't going to be my final answer. I'm not even drawing it too dark. But since I left there, this is the f of x graph. So I can label that just f of x even. I can put equals x squared, but not necessary. So what I'm going to do now is I'm going to list all these ordered pairs. So I'm going to list them in order from left to right. It'll just help me when I'm plotting it later. So I'm going to go down here. That's quite a few points, but the more points I think with these fractions to work with, the better off we're going to be. So we've got negative 3 and 9. So I'm just listing each point I plotted here. So go ahead, list those points. So that's my vertex. Now I'm doing the right-hand side of the parabola. And if you had done a table of values, of course, this is what your table would have looked like. So we have to apply the stretches and reflections first. We can apply the reflection and stretch to the y value at the same time. And then the x coordinate is the 1/2. So we're going to have 1/2 x, negative 1/2 y. So let's apply that. Then what's going to happen? Then we're going to move this graph right 4 and up 1. So I can also go +4 if I wanted on the x and +1. But again, with all these fractions, it's going to be much easier just to shift that graph over. So half of all the x values. So I'm going to fill in the x column first. So cutting everything in half. Notice some fractions are going to come up. That's no problem. It's fine to plot fractions. Sometimes if we have easier numbers, we avoid it, but we don't need to here. So negative 1/2, so we're cutting all of these in half, plus we're multiplying them by negative 1. So we're going to get negative 9 over 2, negative 2, negative 1/2, 0, negative 1/2, negative 2, negative 9 over 2 again. Okay, so I'm going to plot this again. I'm just going to keep this with pencil. This is not my final answer because then after I'm going to do my translations or my movement right 4 and up 1. So negative 3 over 2 is negative 1.5. Negative 9 over 2 is negative 4.5. It's perfectly fine to have that. What's going to happen is the shape is going to be slightly smaller in terms of narrow, right? And it's also going to be reflected over the x-axis. So that makes sense. So we're going to go negative 1.5, negative 4.5. So right in the middle of the square. Negative 1, negative 2. Negative 1, 1/2, negative 1/2, negative 1/2 again in the middle of the square. 0, 0 didn't change. 1/2, negative 1/2, middle of the square again. 1 and negative 2. 1.5 and negative 4.5. So you still have that symmetrical shape. Okay, and again, I'm going to lightly draw this in. You can always erase them after. Maybe not in our notes. We want to know what we did. So because I'm not erasing it, I want to label this. This was y equals negative 1/2 f of 2x. In other words, it was this part right here. I haven't put in the -4 and +1 yet. So now we're going to move this right 4 and up 1. So the vertex is a nice key point to use. So 1, 2, 3, 4 and up 1 is my new vertex right here. Now, rather than counting within here, I'm just going to draw that general shape. So from the vertex, I went 1/2 and 1/2. So they're right in the middle there. I find that a little easier. From the vertex, I went over 1, down 2. And then from the vertex for the final points, I went over 1.5, down 4.5. So over 1.5, down 4.5. So 1, 2, 3, 4.5. Do the same thing over here. Go over 1.5, down that same distance. So this is going to be your final answer now because you've moved it. Now this one had a lot of fractions in it, reflections in that. Not every question you have is going to have every kind of transformation in it. But if you can do one like this, then you definitely have the ability to do any of the other ones that are going to come up. So we want to label that as our final answer, which we can just call g of x. Had I given you just this equation, that's what this would have looked like. My strategy would have been the same, though, of graphing f of x first, applying the transformations in terms of the stretches and reflections first, then moving it.